Hello students, in this video we will review for the end of term exam. So let us start. So here you can see a table with different physical quantities and their formulas and the units. First one is impulse. Impulse has the formula impulse equals F times t and the unit is Newton second. We have discussed in the past that you can find the unit of any physical quantity if you know the formula. So here is the formula Ft for the impulse. So the unit of impulse will be unit of force, which is Newton, times unit of time, which is second. So impulse unit is Newton second. Now, next is momentum. Momentum, we use the letter P to show momentum. Momentum P, the formula is P equals M times V, mv. And as I told before, the unit is the unit of the formula. Unit of mass is kg, kilogram, and unit of velocity is meter per second. So unit of momentum will be kg meter per second. Now this is called delta P. Delta P is change. Actually, this delta is called change. This is used for change. So change in momentum is simply final momentum minus initial momentum. And because it is a still momentum, so the unit will be same, kg meter per second. Next is delta V, which is change in velocity, final velocity minus initial velocity. And we have the unit meter per second. Next is impulse momentum theorem. This theorem, as you can see, has impulse and momentum. This theorem says that impulse, which is Ft, equals change in momentum. Next is kinetic energy. Kinetic energy formula is half mv squared, unit J, joule. Rotational kinetic energy in the rotational motion in ke rot equals half I omega square and the unit is joule, J. What is I and what is omega? So I is moment of inertia, which is mr squared. Normally for spherical bodies, this formula is for spherical bodies, moment of inertia. We will not go into the detail of moment of inertia for this exam because this we have discussed in the term 1. Now the unit will be kg meter squared. Now angular velocity omega looks like W, we call it omega. Omega equals V divided by R. V is velocity, R is radius of that circle or circular path. Now the unit of angular velocity is radian per second. Now next is gravitational potential energy, which is GPE, which is equal to mgh. The unit is same, joule. So what we observed is the unit of all kind of energy is joule, joule, joule. And we know that work is equal to energy, or the what is work? Work is capacity to do work. Uh, what is yeah, energy? So energy is capacity to do work. So work equals Fd. The formula is force times displacement, and the unit is J. Now, this is a force versus times graph. You can see unit is Newton and here unit is millisecond. So this is a graph, force versus time. We can find impulse by the formula Ft. See here before Ft, and there is another way also. which is I'm explaining now. You can find impulse as area under force versus time graph. So if you have a force versus time graph, you can find the area under the curve, and that is equal to impulse. Here is a practice. You bump a wall with 50 Newton force in 2 seconds, find the impulse. So 50 Newton, we will write down first of all what is 50 Newton. This is force F equals 50 Newton. What is t? 2 seconds. So this is t time equals 2 seconds. Impulse equals question mark. We need to find. Now we will write the formula. Impulse equals ft equals 50 times 2, which is 100 Newton second. Now another question. Find the impulse from the graph. We have a graph here. We need to find the impulse. So as I said before in the previous slide, it is area under the graph. So here area under the graph will be half times this base of the triangle, which is 10, and the height of the triangle, which is 20. This is the formula of area of triangle from maths, and we use this formula here to find the area. And from 10 to 20, this is 10 is base, and this here the answer is 100 Newton second. Now next question is related to momentum. Your mass is 60 kg, you are moving with 2 meter per second, find your momentum. So we will write first of all what is 60 kg. This is mass m equals 60 kg. What is this 2 meter per second? This is v, velocity, equals 2 meter per second. What we want, find your momentum. We need momentum. P equals question mark. Now I will write the formula. P equals mv, then equals putting the values, putting the numbers, and m is 60 and v is 2, which is 120 kg meter per second. This is the answer. Now similarly, you can find other variable, like you know this question has mass 60 kg. This you are moving with 100 kg meter per second of momentum. Now you know the value of momentum. Find a velocity. You have to find velocity. V equals question mark. So v will be p divided by m. Now here we will divide. Okay. So p divided by m, which is 100 divided by 60, gives you 1.6 meter per second. Similarly, there may be questions with velocity and momentum and ask you to find the mass. Mass will be P over V. P divided by V, which is 90, momentum divided by velocity 3 equals 30 kg. Because this is mass, so unit will be kg. Now, impulse momentum theorem. As I said before, this theorem is simple. Impulse equals change in momentum. Now there is a question here. A 1000 kg car traveling at 20 meter per second is stopped. Find its impulse. So note down the numbers. M equals 1000 kg. Velocity initial is equal to 20 meter per second, and because this is stopped, final velocity is 0 meter per second. So now impulse equals question mark. Impulse equals change in momentum, which is m times vf minus vi, 1000 times 0 minus 20 minus 2000 Newton per second. Let me put here the delta sign, which I missed here. Let me put the delta sign here, which is, you can see. So this is delta P. Now, always Be careful with the word stopped, because whenever there is a stopped, it means the final velocity is zero. Then translational kinetic energy. Translational kinetic energy is normally kinetic energy. This is energy due to changing position. We have discussed the formula already. SI unit, which is international unit, is joule. Now here, for an object that is initially not moving, its kinetic energy after you throw equal the work you do on the object. So kinetic energy is equal to work done. If the body is not moving before initially, and you apply some force on the body, you do some work, and that work is equal to the kinetic energy, because after your force, that body starts moving. This is important. Kinetic energy is equal to work done. Now rotational kinetic energy. Rotational kinetic energy is formula we have discussed before. I is moment of inertia, omega is angular velocity. Another question: a 3 kg wheel rolls down the road with a linear speed of 10 meter per second. Find its translational kinetic energy. You, m equals 3 kg, v equals 10 meter per second, k equals question mark. We write the formula first here and then put the values. Half times m is 3 times v is 10 squared. That gives you 115 joule. Now another question: a 3 kg wheel rolls down the road with a linear speed of 10 meter per second. Find its rotational kinetic energy. You can see the same number like previous question. M is 3 kg, velocity is 10 meter per second. We need to find kinetic energy rotational, which is half I omega square. Half I, the formula moment of inertia, we discussed in the table, m r square divided multiplied by omega square, which is velocity divided by r. Omega is angular velocity. Go back to the table and you will see that omega is equal to velocity linear divided by r. And so I wrote this, and because it's square here, so square here. Now this r squared divided by r square cancel. So what we have left, half times m v squared. So half times m, which is 3 times 10, which is v squared. So 150 joule. Gravitational potential energy is the work done by the gravitational force, which is the unit of GPE is as joule. We discussed in the table. Now, this table is very, very interesting and important also. So, when you go down, for example, when you leave a ball downward, you drop a ball downward. So, the gravity is positive. Work done by the gravity will be positive, and GPE will decrease because that is going down. So see, GPE depends on the height. So if something is going down, height will be lesser and lesser. So the GPE will decrease. KE will increase because as something going down, the speed increases, and KE is half mv square. So because velocity increases, kinetic energy increases. Now, what about the upward direction? So when you throw something upward, you throw a ball upward. So the gravity will be negative. The work done by the gravity will be negative because the direction is opposite, and the GPE will increase because see, the ball is going up, height is more, increases, so GPE will increase. And kinetic energy, because you're throwing upward, the ball will be slowing down, so velocity will be slowing down, so the kinetic energy will decrease. Now, this is also very important slide. GPE at the top height, that is maximum. GPE will be maximum because the height, and at the bottom that will be zero. Near the floor, the the GPE will be zero. Kinetic energy at the top, because something when it reaches at the top has zero velocity and then starts coming down. So at that top position, the kinetic energy is zero. When, on the other hand, when it is near the bottom, almost touching the bottom, it will be maximum.